In this video, we're going to be looking at solving exponential equations where you can't get the bases to be the same. For example, solve the equation 5 to the x equals 3. Now in the past, when we have an exponential equation, we try to rewrite each side of the equation so that they have the same base. So if this had been 4 and if that had been 8, 4 and 8 have a common base of 2 and can be rewritten like that. Here, these guys don't have a common base. So instead what we can do is that we can apply logarithms to both sides, meaning we can do this. We can say that the natural log of 5 to the x equals the natural log of 3. So as long as we are applying the exact same type of log to both sides of the equation, if what we have up here is true, then what we have down here is going to be true. And you might say, well, what's the purpose of doing that? Well, the big purpose is so that we can do something with this power. See, right now the power's in a weird spot. It's up in the power and I can't do anything with it. But when I apply a logarithm to it, and we apply properties of logarithms, we know that the powers can go out in front. And so this can be rewritten as x times the natural log of 5 equals the natural log of 3. And when we look at this, here's the only place where we see the variable. Everything else is pretty simple. I mean, I know it says natural log of 5 and natural log of 3, but these guys are just numbers. They're constants, and we can treat them as such. So in terms of, how do I solve this? Well, to get x by itself, you're going to divide by this factor that is not the variable. So we divide both sides by the natural log of 5. So these guys reduce, and x is equal to the natural log of 3 divided by the natural log of 5. Now, one thing to note here is that that's an exact value. The natural log of 3 divided by the natural log of 5 is exact. And in a lot of these problems, especially when you're doing them through my math lab, they may say give an exact value, but they may also say to give a decimal approximation, say rounded to the nearest thousandth. Okay, so if we do that, so that means x is approximately equal to, and this is where you need to go to either a graphing or a scientific calculator to type this in and get your answer. So to type this in, we have the natural log of 3, but notice when you type the natural log, parentheses will automatically open. So when I type 3, I've got to make sure that I close that off. If I don't close off those parentheses, the calculator still expects that you are inside the natural log. So by closing it off, you say, okay, I'm done with this natural log. Then you say divided by, you have another natural log of 5, and close that off. So here is your decimal. So 0 point, let's see, rounded to the nearest thousandth, so that's 3 decimal places, 0.683. All right, and a quick way to check your work when you're doing these problems is to take your answer, take this output, and press the store key. Now remember, the store key is this guy right here. So we're going to press the store button, and it's going to say, okay, we're going to take your answer, arrow, so I'm going to store it into something, and let's just press X. So now when I type in X, it's going to be this decimal. So we're going to verify that this is the correct answer by typing in 5 to the X. So 5 raised to the X. If this is the correct answer, it should give me 3. And it gives me 3. Everything works out nicely. Now, if I had just done this approximation, let's see what we would have had. 5 raised to the 0.683. I get a number that's really close to 3, so I'm happy with that approximation. Even better, having that exact value is really what we're going for. Okay, let's try another one that has just a bit more to it. So let's look at 3 raised to the 2x minus 5 equals 2. Again, it'd be nice if you could rewrite each side of the equation so that they have the same base, but you can't. So just like in the last problem, we're going to apply logs to both sides. Now, I'm using the natural log. You may use the common log or any other log that you want. But I don't know, natural logs seem to work out nicely most of the time. Alright, so remember, the whole point of us applying logs to both sides is so that I can take this power right here and bring this out to the front. Now, when you do this, you have to be very careful about how you write it. If you write this, if you write 2x minus 5 times the natural log of 3, that is wrong. Because it's that entire group that's the power, and so you're bringing that entire group out in front. So it must have parentheses. And then on the other side, we just have the natural log of 2. All right, so you've got a couple of different ways to play this. You can, right now, you could distribute the natural log of 3 into this. But for this problem, I think that's a bit unnecessary. So instead, if you divide both sides by the natural log of 3, and the reason I'm doing that is because you have the set of parentheses times that natural log of 3. So if I divide by the natural log of 3, that guy's going to go away, and that's going to help me get closer and closer to getting the variable by itself. And so now we have 2x minus 5 is equal to the natural log of 2 over the natural log of 3. Again, that's just a number. It's not a very pretty number right now, but it's just a number. And really, if it weren't something that looked this nasty, think about the steps you would take to get x by itself. So regardless of what you see on the right side of the equation, you know that in order to get x by itself, you're going to have to add 5 first and then divide by 2. So let's do that. All right, so we're going to add 5 to both sides. Unfortunately, 5 does not add very nicely to what's on the right side. So that means we're going to need to write this like that. And then we finish getting x by itself by dividing both sides by 2. And see, this is where things look a little bit messy because you've got a fraction in the numerator of a fraction. It's kind of gross, but you know what? For right now, I would accept this. So we have this plus 5 all divided by 2. All right, so this is exact. And let's figure out what would be a decimal approximation to this. All right, so we've got to be very careful about how we type this in. Now, everything up here is in the numerator. So you're going to have to be very careful about your use of parentheses. So let's open up a set of parentheses for this guy. I'm doing the natural log of 2, close off the parentheses for the natural log, divided by the natural log of 3, close off those parentheses. So that set of parentheses is for that natural log, this is for the other natural log, but you still have the open set of parentheses because we still have to do plus 5. All right, yeah, so we got plus 5, close off that set of parentheses, and we're dividing the entire group by, what do we have here? Yep, by 2. And this is our decimal approximation, 2.815. Now let's check to make sure that this is okay. So, just like we did in the last problem, I'm going to take this, I'm going to store it into x by pressing that store key and then pressing x. And I'm going to type this expression. So 3 raised to the, now be careful. If I do 2x minus 5 like that, you see that it does not equal 2. So here's the problem. We didn't use parentheses correctly. 3 raised to the, open up parentheses because you have to put 2x minus 5 as that power. So using the parentheses, we'll say, okay, everything here is going to be that power. And we get 2. So everything checks out. Now, there is another way for working this. So right here, let's kind of rewrite this over here and see what we have. And this is going to be useful for the next few problems that we look at. Suppose that we had distributed that natural log of 3 instead of dividing it. when distributing, you would have had 2x times the natural log of 3 minus 5 natural log of 3. Please make sure that you focus and you understand that this is the only place you see your variable. So now let's take that guy and start getting it by itself. And of course, the first step that you would do would be to move 5 natural log of 3 to the other side. So those guys reduce. 2x natural log of 3 is equal to, and I know that both of these guys are natural logs, but we cannot combine them because they are not the same kind of natural logs. One is the natural log of 2, the other is the natural log of 3. All right, well, to finish getting x by itself, here we go. This x is connected to both the natural log of 3 and it's also connected to that factor of 2. So we're going to divide by those factors. So we're going to divide by both 2 and the natural log of 3. So divided by 2 natural log of 3 over here. So the 2's reduce, the natural logs reduce, leaving you with just x. And x is equal to this big fraction here on the right. So these answers are the same. They are equivalent. This one's just a bit nicer to look at. And we can check this, verify that it is correct. So again, make sure that you pay attention and that you use parentheses correctly. Even down here, because it's not just the natural log, but because it's got 2 times the natural log of 3, you want to make sure you use parentheses for that. So parentheses for the numerator, the natural log of 2, close for the natural log, plus 5 natural log of 3, close the natural log, close the numerator, divided by, so open parentheses right here, 2 natural log of 3, close the natural log, close the denominator, and you see that the decimal that we get right here is the same decimal that we had down here, approximately 2.815. So everybody's happy, right? All right, now let's see what happens when these guys get a little bit more complicated. So let's look at solving 7 raised to the x plus 3 equals 5 raised to the 3x plus 1. And again, 5 and 7 don't have a common base, so we're going to have to take the natural log of both sides, or whatever log you want. And again, the reason that we do that is so that we can take these powers that contain the variable that we're solving for. We can bring those powers out in front by using the properties of logarithms. So this power will go in front, and this power as well will go in front. And just like we saw in the last problem, you want to make sure that you use parentheses. So it's going to be parentheses x plus 3 times the natural log of 7. And on the right side, 3x plus 1 will be in parentheses times the natural log of 5. All right. Now, notice that we have x on both sides of the equation. So I can't do what I did in the last problem and divide both sides by the natural log of 7. I mean, I could, but it's not going to get us anywhere that's good. Instead, we want to distribute this. So this is going to be x times the natural log of 7 plus 3 natural log 7. On the right side, we have 3x times the natural log of 5 plus, well, the natural log of 5. If you want to write the coefficient of 1 in front of it, if it helps you sleep better at night, go for it. What we need to do right now, and this is going to be a common trick that we play a lot in algebra, when you have x in 2 different pieces and you're trying to get x by itself, anything that has x needs to go on one side of the equation. If you don't have x, you go on the other side. This isn't really new, it's just going to look just a little bit differently here with these logarithms and the exponentials. So to do that, I need to move this term from the right over to the left. So now everything with x is going to be on the left. But I need to then move this term, this constant term, I need to move him to the other side by subtracting it. And now we're going to rewrite. So we have x natural log of 7 minus 3, x natural log of 5 equals the natural log of 5 minus 3 natural log of 7. So we're getting closer. We have everything with x on one side. Unfortunately, these guys don't really combine because they're not like terms. So here's the trick that we use quite often. These guys both contain x. So let's factor the x out. Going back to good old factoring techniques, these guys have a common factor of x, so I'm going to factor that out. That leaves me with the natural log of 7 here, minus, I'm taking out just that factor, so I'm left with 3 natural log of 5 from the other term. It's just factoring. And then we copy down the right side of the equation. Alright, well, how do you get x by itself? This is x times that group. Well, keep in mind that the natural log of 7 minus 3 natural log of 5 is just a number. So if I had 3x equals something, you know you would divide both sides by 3. So here, whatever that decimal is, I don't really care. I'm going to divide both sides by that. Now I'm going to keep all of the natural logs here. I'm not going to put this into my calculator yet, because if I try to convert these guys into decimals early on, it's not going to be exact, and you're going to have to track your decimals every single step of the way. Instead, I'm just tracking natural log of 7, 3 natural log 7, things that are pretty straightforward, right? Easy to remember, easy to copy down. So those guys go away. And then I have this expression on the right. Again, with all the natural logs, it looks messy, but it is exact. So here's our exact value. Now we need to figure out what is this decimal approximation. And again, one of the biggest issues students have with getting the decimal is typing it into the calculator. So remember where your parentheses are, where do you open them, where do you close them. Also make sure that you have parentheses for the whole numerator and parentheses for the whole denominator. Alright, so let's see what we have. Big parentheses, natural log of 5, close the log, minus 3 natural log of 7, close the natural log, close the numerator. Okay, make sure you can see how those parentheses are pairing up. Divided by, okay, that's the big fraction. Open parentheses for your denominator, natural log of 7, close the parentheses, minus 3 natural log of 5, close the parentheses for the natural log, close for the denominator. So x is approximately 1.467. Alright, so let's take this guy, store it into our variable x. Alright, that guy's ready to go. Now we're going to come back to the original problem and we're going to check this out. Now, it's not going to be as easy to see as the other problems where we typed it in and we just needed to make sure that it was equal to 3 or 2 or 5 or something like that. We're going to type in each of these expressions to see what we get. So 7 raised, don't forget your parentheses, to the x plus 3 is that number. Okay, don't really care what that is. I just want to make sure that when I type this, I get the same number. So 5 raised to the parentheses, 3x plus 1. We get the same decimal when we plug that into both sides of the equation, so we know that what we have is true. Alright, let's do one more, just like this, just to make sure that we get this down. And remember, at any time that you're watching these videos, feel free to pause, try to work these problems out on your own, and then come back and watch the solution. See if you get the same thing that I do. If you ever have questions, let me know. All right, so here we have one side with 6, one side with 2, and you might think, oh, well, 2 goes into 6. It does, but for exponential equations, they have to have the same base, and we can't really do that. Dividing by 2 doesn't work here because you're dealing with exponentials. So instead, just like in the last problem, let's take the log of both sides. And if you paid attention to what we did in the last problem, you're going to see that this is pretty much the exact same thing. It's just different numbers, different signs, but the steps are the same. Remember, we apply a log to both sides in order to get these powers out in front, because we bring them from being in the power to being down on the level where we can actually work with them. Again, make sure that you use parentheses here so that you are being precise in everything that you do. And over here we get 3x plus 5 times the natural log of 2. All right, just like we did in the last problem, we're going to distribute. It looks a little bit messy, but it's going to be okay. So minus 3 natural log of 6 on the right side, 3x times the natural log of 2 plus 5 times the natural log of 2. All right, as before, we identify these two terms that contain the variable x, and it's our job to get these guys on the same side. So, first and foremost, we're going to subtract 3x natural log of 2 from the right to move it to the left. Okay, you're gone. And if we bring all of the variables to the left, the constants need to go to the right side. So I do that just by adding, in this case, 3 times the natural log of 6. All right, now let's see what we have. So 4x natural log of 6 will not combine with minus 3x natural log of 2. That's fine. We don't really need it to combine. On the right side, 5 natural log of 2 plus 3 natural log of 6. And again, we play the same trick here. You're going to take that common factor of x, and you're going to factor that out. This is how we get x by itself. So, x is now by itself out here in front, and we factor that out, and we're left with, from this first piece, 4 natural log of 6 from here, 3 natural log of 2. So remember, the reason that we wanted to factor that out is so that now we only have one instance of x, this guy right here. And to get that guy by itself now, we divide by this constant that it's connected to. So factoring means rewriting as multiplication, so we're going to undo that through division. All right, take care of this on the other side. All right, so now these guys go away, and we have our exact answer. So I hope that you see that with practice and patience, these problems really shouldn't be that bad. It might take a little bit of time, but the steps that we do for each problem, they're the same. So here's my exact value. I now need to figure out what is the decimal approximation, and then we're going to go and check that guy. All right, so make your notes to remember to do parentheses for the whole group that's in the numerator and the denominator. So big parentheses, 5 natural log of 2, close the natural log, plus 3 natural log 6, close the natural log, close the numerator, big fraction, so we're dividing by, open up the parentheses. 4 natural log of 6, close the parentheses, minus 3 natural log of 2, close. Close the denominator. Alright, so our decimal approximation, 1.738 when rounded to the nearest thousandth. Again, let's check this though. I'm not above making a mistake. I'd hate to do that here and be recording it and putting it on YouTube, so let's see what happens. So let's store this into X. Alright, now come back up here. Let's type in both the left side and the right side of the equation to see what we get. So 6 raised to the, don't forget your parentheses, 4x minus 3. Alright, again, it's just a number, I don't care what it is. I just need to make sure that when I type the other side of the equation that I get the same number. 2 raised to the power 3x plus 5. Huzzah. We get the same value, we checked our work, so we know that we're okay. We know that we've got the right answer. Alright, so the big takeaway here is that if you don't have, or if you can't get the same base on both sides, you apply logs, whether it's the common log or the natural log, and you go through the process of trying to get x by itself. Sometimes there's not much to do to get x by itself. Just here we divided by the natural log of 5. Down here it got a little bit more complicated, whether we did it this way, by dividing, adding the 5, dividing by 2, or here, which more closely resembles the last two problems that we did. Whatever way, your decimal at the end is going to be the same. And once you get your decimal, check it with your calculator. It doesn't take long to do that, and then you can know beyond a shadow of a doubt that your answer is correct.